Good. Hi folks, sorry about the delay. I was trying to load up on the computer here and I was having technical difficulties, and obviously with technology that's sometimes what happens. So happy Monday. Sorry to put you on hold. I'm here, we're here. The museum is still functioning, and hopefully you had a great weekend. Sciencing and doing whatever you needed to do. It was a little cold, some snow, right? So we're working at it. We're getting at it right now on Monday, and we're going to be talking about things that happen naturally outside in nature. Specifically, today we're going to talk about lightning. So I thought maybe this is a really easy experiment you can do at home, but let's first talk about like how lightning is formed. So you know, we've been doing experiments throughout these last couple of weeks here, and lightning is formed way up in the sky, right? And lightning is electricity. So when you have all those ice and those cool molecules mixing up in the clouds, right, that produces electricity up in the clouds. And then electricity is so very hot, right? And when it's so very hot, what happens is hot expands. And that expansion, right, up in the clouds causes, not lightning, boom, 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 thunder, right? So let's think about this for a second. So I have my water bottle here, and I've done this experiment before, and I want to show you the expansion and the heat and what can be produced on a binary level here. Let's start real quick with like just a cloud. So you know my cloud in a bottle experiment. So if you can look right here, it's showing that this bottle is reading 72 degrees. Now, if I pump air into my bottle, and that's what I'm doing right now, I'm pumping air into my bottle. Okay, what's happening is all of those molecules, right, and I have a little bit of rubbing alcohol in there, and that's causing a little bit of coolness. So if it's cool in the bottle right now, and I pump air into my bottle, look, you can see it. I'm pumping air into my bottle. What's happening is those molecules are starting to move real close to one another. And what's happening is they're getting closer and closer together, and it's causing them to get warmer and warmer. And if you notice, my temperature is starting to rise on my bottle. So it's going from blue to red. So it's going from 72 to, I believe, about 75 to 79 degrees, right? And what happens is, okay, that expansion is causing the warmth in there to mix with the cool. And if I release that air, look, I get a cloud, okay? So clouds are formed through that warm and cold air. But lightning is formed by that electricity in the clouds. It's up there because of those ice molecules and those particles that are mixing together up there. So that's causing electricity in the clouds. Now, how does that electricity get down to us? How do we see it? Well, we know, right, that sound, okay, doesn't travel as fast as light. We can hear it, but we see the lightning very quick, and then we hear the rumbling of the sound. Now, we can make thunder, right? We can make thunder by just using a can and an old slinky. So listen to the thunder, right? Thunder. Now, we hear the thunder, and then we see, right? We see lightning, but we see the lightning first because light travels is faster, right? Light is faster than sound. So I thought it would be really cool. Can we make lightning? How would we make lightning? Unless you were a superhero and you had superpowers, you could strike lightning right from your fingertips, but we don't have that power, right? So with just using some household materials, ready? And these are the household materials you would need to do this project, okay? You need a thumbtack, a little thumbtack. You need a pencil with an eraser. Pie tin, right? Some wool fabric. Now, you could use nylon. You could use a different amount of fabric. So here's where your testing comes in and being a scientist and modifying things. But I found that wool works the best, okay? Wool fabric and a piece of styrofoam, polystyrene. Now, you're probably saying, well, what do we need the styrofoam for? Well, styrofoam cups, polystyrene, balloons that are made of latex or rubber, don't necessarily carry static. Okay, some people may get confused by those carrying static. They don't carry static. what they do is they're good conductors of electrical current. Styrofoam is a good conductor. So, styrofoam, okay, great conductor. So the first thing that you want to do, now again, we're going to try and make a little electrical current here. We're not going to make a humongous lightning bolt, but we're going to make an electrical current, okay? You're going to take your pie tin. And you're going to take your little thumbtack here, okay? You're going to push your thumbtack through the bottom of your pie tin up to the top. Now don't poke your fingers, be very careful. Now to protect your fingers, you're going to take that eraser on your pencil and you're going to stick it right there on top, okay? Right there, just like that. So this is going to act like a handle, okay? Because we don't want to touch the pie tin after we've charged it, okay? So how do we charge it? So we're going to put our pie tin off to the side. We're going to take our wool fabric, okay? Styrofoam, and you're going to rub your styrofoam, right? Few minutes, few seconds, you decide, okay? If it doesn't work after rubbing it for 20 seconds or 30 seconds, try it for a minute. But what we're doing here, what we're attempting to do is generate a little bit of an electrical current. We're going to build up that static electricity, right? Okay, so we're rubbing our styrofoam here. See what we can do. Rubbing, rubbing. Now be careful not to touch or discharge any of that electricity. So I'm going to take my fabric, I'm going to move it over here. And you're going to take your pie tin, grab it by its handle, and place it right here on that charged styrofoam. And what we're going to attempt to do, we're going to touch the pie tin, and we're going to make a little spark or static charge. All right? Let's see if I can do it. Ready? Now, you should feel the little shock here. Oh, no, just kidding. I didn't get shocked. But I did feel a little static here. So I'm going to try it again, and I'm going to see if the camera can get in real close here. All right? So we're going to rub this. Build up a lot of static electricity here. I'm tearing the styrofoam apart. Okay? We're building up that charge. Okay, again, grab my pie tin, put it right here, and I'm going to touch right here in this area. Let's see if we can get it. See if the camera can see it. Oh, I felt that one. So I got a little bit of a shock. Now kids, parents, grown-ups, grandma and grandpa, nothing big. Little teeny tiny charge, but I did feel it. Now, you may not see it because of all the light I have in here, but if you were to turn the lights out, you may be able to catch that little static charge going from the pie tin to my finger, okay? Nothing big. You'll get a little jolt there. Nothing it's very harmless to any of the children. Little hands, you're gonna have fun with this. So, easy way to make a lightning bolt. Now, is it the lightning bolt that we commonly see outside? No. And to be quite frank, some people, animals are afraid of the lightning and the thunder and all that loud booming and craziness that goes on outside. But there's so much science that goes in behind that, okay? So I encourage you over this week here, because we're going to get some rain, right? And if there's some thunder, to kind of observe what's going on outside. Remember, hot air rises into the cool air, and when those things mix, okay, albeit on a very, very, very slow basis, you're going to get a cloud, kind of like what we made in our bottle here, hot and cold air, right? Now, if those air masses, hot and cold air, mix very quickly and move one against one another, remember we talked earlier, that swirling, right, that hot air that rises in that cool air could flip that air pocket, and you could create a vortex or a tornado or a typhoon, but we wouldn't want that. So hot air rising into the cool air very slowly makes the cloud. Okay, the clouds get charged with electricity because all of those ice particles, all right, and that particles up in those clouds there, they form that electricity. And when those electrical currents bang against one another, okay, that vibration, because of the electricity and that hot current from that electrical charge of that lightning bolt, okay, they bounce off the clouds there because heat expands. And that's what you hear. You hear the thunder. Now, it's got to get to the ground, right? That's the lightning. That light, that flash of light, that's the lightning bolt that we're looking for there, okay? Now, again, you wouldn't want to stand outside during a lightning storm. Very dangerous. Don't do that. But it's interesting and it's really cool to observe and see. And on a very, very basic level, you can create your own lightning bolt using the pie tin, the pencil, some styrofoam, and your grandma or grandpa's wool socks, right? Those are probably going away for the wintertime because it's getting too warm outside. Who wants to wear wool in the summertime? So, long story short, easy way to utilize things in your own home. And guess what, folks? I'm in the museum We're starting back and amping up to start doing things for you in the community. We're launching our little birthday bash this Saturday. Oh, Wow's turning 9 years old, right? We're 9, we're grown up, all grown up. We're going to be doing some virtual birthday party demonstrations on Saturday, so tune in. Every hour there's going to be something new, so tune in and find out what Oh Wow staff is doing what for the birthday, okay?
We have a question.
Sure, we have a question?
From Riley. It says, can you hear it?
Can you hear what? Yes, Riley, that's great. Great question. If you listen very carefully and put your ear down close, now don't touch the aluminum tin, you can actually hear that static charge going from the pie tin to your finger. So great question. I think it's most important though, now remember, okay, what travels faster, light or sound? Light, right? Speed of sound, right? So you should be able to hear it, but you're going to see it first, okay? So great question, Riley. And Riley, you know what? I love you to death because you've been tuning into all the Wow Pals and all the videos that have been, going out there for the last 6 weeks or so. So you know what? Why don't you film yourself doing something or making a static charge, all right? See if Dad can help you out or Mom can help you out, right? Let's see the static charge. I want to see you tape yourself making a bolt of electricity, all right? So great question. Hopefully, again, you're still sciencing. Again, we're working on these STEM sacks. We're working in the museum here. We're going to start producing some more curriculum, and we're going to be posting it on Facebook and Instagram and TikTok and YouTube and on the line, whatever may be. But the most important thing is we need you. We need you to like us and share us, and most importantly, support us in whatever capacity. Support one another. And more, I'm going to add a fourth to this. We need you to celebrate with us. We need you to celebrate on Saturday with us for our birthday, 9th birthday. Okay, because now we're out of the walking shoes, the training wheels are off, we're riding our bicycle and we're running. That's today's lesson, folks. Heat rises, clouds, lightning, boom, 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 thunder. We can create it all in your own home. Hope you enjoyed the lesson. Glad to see you. I miss you. Look for us on Friday. There's going to be a live segment on WFMJ. We're going to be celebrating our birthday this Saturday. I hope to see you. Okay? Thanks for watching. Miss you greatly. See you soon.